afternoon and welcome to Erwin Insights 2020. This session, DIO5, Powering Your Data Lake Initiatives. And I'm excited to have joining me for this session, Sam Benedict and John Carter from Erwin. And one of the things that's really cool and up to the minute late breaking stuff is we just recently made a very exciting announcement on a new solution offering called Erwin Cloud Catalyst. And John is going to be talking about that in his part of the session later on. So now without further ado, I'm going to hand it over to Sam and he's going to take you through Powering Your Data Lake Initiatives. Go ahead, Sam.
Thanks, Marianne. Hi, everybody. Sam Benedict here. You've probably seen me or heard me on webinars in the past. Going to take you through a few slides here and then hand you off to John Carter, who's our resident expert on automation and the director of our automation services. He's the guy that makes the magic happen. So as we go through here, we're going to talk about just a handful of things, some observations, some of the things that we're seeing in the market. For example, this first slide, we're talking about lots and lots of data. You know, IDC, Gartner, Forrester, everyone's talking about the explosive growth of data from traditional data sources, from IoT, just all sorts of new data sources coming at us each and every day. And businesses continue to struggle with managing that data. And we talk about, today we're going to talk about data lakes, we're going to talk about cloud instances and more efficiencies and ways to deal with larger volumes of data. And we'll talk a little bit about how we got here, right? And what's important when we get to where we're going, and that's high efficiency, highly governed, and highly auditable databases, because we're in a new era of data privacy, data protection. And so the things that we could ignore in the past are not so easy to ignore today, not without massive penalties anyway, when it comes to things like CCPA and GDPR. And by the way, there's new legislation coming from the Federal Trade Commission, probably in the next year, that will represent a United States standard for data privacy. Much like GDPR, a little bit of CCPA folded into it, I'm sure, but we've got to get ready for that. And if we're not ready, it can be a big road to get there. Or if you use the right technologies, it can be a fast road to get there. So we're going to talk about that. Let's talk about data lakes and where this all originated. So we have industry influencers, the Gartners, the IDCs, the CIO magazines, all of these bloggers on the market that are talking about things we need to do and where we need to go. And it drives behavior. Now, like it or not, leaders want to be cutting edge. Leaders want to be out in front in their industry. And when we talk about data lakes, we had every CIO in the world wanting a data lake. Whether they knew why they needed a data lake or not, we've got to have a data lake. Get me a data lake at all costs. People around them were questioning. People who knew the data lake technology were saying, why do we want a data lake? Do we really want to do this? I don't know if we have the volume of data. I don't know that we really need it. Maybe we don't have the hardware. Maybe it's a massive expense that we really don't want to bear for something that's not going to give us what we need. And it didn't matter. We were going that direction anyway because it's cutting edge. And the bottom line is that CIO who drove that data lake, whether or not he needed it or she needed it, they were on to their next job by the time that data lake had failed. And there's stats around that. So we talked about also one of the reasons and the ways we got people to go along for that ride was ease of use, right? Just throw it in the lake. No more data mappings, no more documentation, no more audit, balance, and control. We can just put it all in the lake. Everything's going to be easy from here on out. And it seemed like a dream come true. And then the fact of the matter is, it really turned into a nightmare, right? In 2016, Gartner estimated that 60% of big data projects failed. Read big data as data lakes. A year later, Gartner analyst Nick Hudaker said his company was too conservative with its 60% estimate and put the failure rate at closer to 85%. And that, when you think about the millions of dollars, probably in the billions, that were spent on data lake initiatives and the root cause of how we got there, there's a few things to reconsider here. So first off, we need to think about the things that we're doing and build smart data structures that make sense for the business. I think we've gotten a whole lot better at doing that in an age of data science, in an age of predictive analytics. All of those things have gotten better. The things that we need to focus on now are data lineage and management and making sure that we have proper documentation for all of our data sources interim repositories and targets, and then we're able to track data, whether it's going to a data lake or a cloud instance on Snowflake. It's very, very important to make sure we understand how the data came into our company, how we're using that data every day, and where it's flowing in our architecture, not just for privacy and compliance concerns, but for operational concerns. Do our data scientists really understand how good, bad, or ugly that data is? And can the things that we do as data practitioners in our DevOps process lend to the success of the overall business decision-making process that we're using analytics to drive? And the answer is yes, everything can get better. For example, if we just look at this slide here, any data analyst, in fact, anyone, data analyst or not, would look across this picture. You can derive a lot of things just by looking at it. We've got a little bit of flour, some vanilla, chocolate chips and butter, sugar, and a chimpanzee. Those things all go together beautifully, except for the chimpanzee. He's out of context, and we don't know why that is, but it's an anomaly. And if we don't really understand what we're looking at, we might think that something has gone terribly wrong, right? So we're going to talk about the importance of lineage, the importance of understanding and curating data from end to end so that we don't end up with chimpanzees in our chocolate chip cookies. Now, when we talk about data, we've gone from having no data to having to know our data almost overnight. The advent of GDPR really has driven data governance to new heights. 10 years ago, 12 years ago, data governance was a nice to have. It was something that everyone was striving to do because they knew there were benefits to it, but there was a big cost to it, and nobody was willing to bear the cost given the fact that there were not any real clear financial benefits, right? So now there's not necessarily a financial benefit, but there's an offset, right? No fines, no compliance, massive fines for GDPR and CCPA, and we're going to see those continue to go up. And they're going up because it makes it real for everybody. Basel, for example, in the banking industry was widely ignored by banks because it was cheaper to pay the fines than to correct the data and get their house in order. So now we've got legislation that has teeth. We have to find a way to be compliant. And if you look at the stats here, what are the most serious bottlenecks in your organization's data value chain, right? Understanding the quality of the source data, synthesizing disparate data sources to serve the use case and hypothesis. These are data science related things. They're reporting related things. And number one here, documenting complete data lineage, 62%. That's a pretty big struggle. Understanding the quality of the source of the source data. Again, if we don't know how good it is when we got it, how can we trust it when we're putting in a data set for a data scientist or we're running reports off of it? It all becomes very important that we understand where the data came from and all the way through the process where it ends up in our email systems and extract files and in our reports. So this just emphasizes the importance of it, but it also calls to attention that it's a struggle, right? And it's a struggle for people that maybe don't know that there are products on the market today that can make this less of a struggle. I'm not going to say they make it easy because that would imply that it's a push button solution. There are no miracles, right? Not in data. Everything takes work, but we can make that work easy. We can make it automated, and we can take out as much of the opportunity for human error as possible in that overall process. Now, when we talk about Erwin has long been known for their data modeler. If you've been on other sessions today or in the previous days, you'll know that we've talked a lot about how Erwin has expanded their footprint into things like enterprise architecture products and business process modeling. We talked today about Data Intelligence Suite, which is our Erwin's latest product. This product has been around for about a decade. It has many Fortune 50, Fortune 100, and 500 customers, but it also has many mid-cap and low-end cap customers leveraging this product to drive their data practice to do things better and smarter and faster. So today, when John's talking, he's going to talk about our data catalog suite that's going to talk about mapping, metadata management, and automation. And primarily what we're talking about here is taking our metadata, connecting it together with our mappings, whether that's from legacy source or legacy mappings or legacy systems, and mapping it to where we want it to go in the future state, or maybe we just want to stay where we're at. Maybe we've already got a Snowflake instance that we really like, but we rush to get there and we really don't know the overall lineage of that environment. Certainly happens. Now, down at the bottom of the page, you're going to see standard connectors and smart data connectors. Standard connectors is where we're going to harvest all of our data at rest. Once we've got that data at rest in place, we can then take code, transformative code of all different types, ETL code, SQL strings, stored procedures, macros and packages. All of it can be reverse engineered, tied together with the metadata, and really paint a very clear picture that's detailed at the system, environment, table, and column level for our data lineage. That's done using our smart connectors. Those smart connectors are bidirectional. That means once we've documented our legacy, we can pick it all up. John's going to go into more detail on this, and we can push it wherever we want it to go, and I'll leave it at that. Now, when we talk about this overall platform called the Data Intelligence Suite, we're really talking about these categorical advantages: harvesting metadata, analyzing, structuring, governing, and creating great visualization. And when we talk about visualization and the DI suite, we're not just talking about heavy lifting DevOps activities. We're talking about business intelligence. We're talking about business graphs that show the lineage of business objects and how those business objects relate to technical objects. So when we talk about a business semantic graph, you'll hear that term a lot from Gartner and Forrester and the analyst groups. That's really what we call a mind map, fewer syllables, but it's the same concept. We're looking at an object and we're seeing all of the relationships around that object and giving greater context. In fact, incredible context to any business viewer or technical viewer that's trying to understand how things all fit together. Now, we do graphics for our lineage and for our sensitive data discovery and categorization. All of those things are graphically represented because a picture is worth 1,000 words. And I think you could argue that a mind map or that business semantic graph is worth several thousand words when you see it. Now, coming here into our overall solution, you've heard companies say before, we have all these different product lines, aren't they wonderful? But they're bolted together. They're not cohesive, and they're not basically developed to work together. At Erwin, we believe that everything should fit together systematically and cohesively so that we can share metadata. Starting with our models, we can pick up our models, we can ingest those into the DI suite and carry on after the model into the DevOps process, into the data governance process. So nothing is a throwaway, and we don't have any awkward handoffs where we introduce a lot of opportunity for human error and manual effort. Everything should be seamless and get you from start to finish with as much automation as possible, and you'll see that as we move along here. Visualization and navigation, again, data lineage that takes you from the top tier system level to the environment, to the tables, down to the columns in a single view where I can drill up, drill down, and see all the transformations from end to end. And likewise, interactive mind maps that give me the ability to drill in, change classifications of sensitive data, and really see how it all fits together with a center point. That center point can be a data tag for GDPR, for PHI, for whatever you like. It could be a business term, or it could be a technical column. This is a larger expanded view of a lineage diagram. This lineage diagram came directly from a reverse engineered Informatica job. So we take that XML, the native XML of Informatica, we parse it, we pick up all the embedded scripting, and we create lineage views that make it very easy for anyone in the company to understand how the data flows from end to end. This happens to be a dual lineage view that's showing us bidirectional movement. We can also do forward and reverse and separate those views to make them even easier to look at. And the idea is that now we can parse and look at everything individually, and we can see a macro view of how our data is moving through the architecture. This is just a closer view of our mind map. You're seeing here change of address in the center. That becomes the center of the universe for the mind map. And off to the left, all the technical columns. Off to the right, we've got our business rules and our business terms, and we can see the business lineage of where those live. So which catalogs and which particular terms they relate to, and also a little bit of context around what that relationship is. it's represented by, it's governed by, it's a child of, it's a parent of. All those context cues are also woven into this interactive mind map. And if I want to click anywhere on the map and go into the metadata or go directly into a glossary, I have that advantage. So I don't have to jump in and out of different windows. I can just work right in this window and do many things that help my, my cause. So back to context and clarification of meaning. If we told you that we were going to teach a class to a bunch of chimpanzees on how to make chocolate chip cookies, the picture we had earlier would have made a lot more sense. And that's the magic of context. If it's taken out of context, you're left to wonder what's going on. It creates confusion. But with just a tiny bit of context, a picture, and those pictures in our product are represented, by the mind map, by the lineage views, by the dashboards. It brings everything together and helps everyone understand how it all fits. And with that, I'm going to turn over to my colleague, John Carter, director of our automation team, and he's going to take you through some of the more technical details of automation. Over to you, John.
Thank you, Sam. I am John Carter, and today I'm going to talk to you about a new offering from Erwin that is a Cloud Catalyst. The Cloud Catalyst is a suite of cloud migration and data governance tools that help organizations quickly and safely migrate data from on-premise database solutions to the cloud, and then govern those assets throughout their lifecycle. Yeah. Today, there are many use cases that can be covered through the Cloud Catalyst suite. Today, I'm going to cover some of the top use cases that we've utilized this to implement with some of our clients. Right? First, identifying that architecture, migrating schemas, ingesting the data, right? And migrating the ETL processes that currently exist to that new cloud target. Even helping out the BI world with the semantic model conversion, and then governing that data as we move forward. So the first step is to identify the components within the current architecture that you look to modernize. We would all love to modernize our sources and have clean, consistently structured data every day, but that doesn't happen. Luckily, Erwin has a set of tools that will help model, design, and accelerate the ingestion of those disparate sources. However, when we do find items that we wish to modernize, such as legacy on-premise ETL tools or databases, we then have to construct a future state architecture. Once we've identified what that architecture is, Erwin automation experts can come and assess the future and current state architectures and identify opportunities where we can apply metadata-driven automation in order to accelerate the process of the migration to cloud. Once we have identified and prioritized those opportunities, we can then begin to configure smart connectors specifically to the environment in order to make the process as painless as possible. The first step in the process is to migrate that database schema. With Erwin Data Modeler, we now have native connectivity to cloud data platforms such as Snowflake. This means that we can reverse engineer existing Snowflake structures. We can do native modeling within Data Modeler on Snowflake environments. And important to the Cloud Catalyst suite, we can convert models that are reverse engineered from legacy database systems into Snowflake effortlessly and accurately. All right, once that database structure is migrated, we then need to bring in Data Intelligence Suite, where we provide source to target mappings from that legacy source to that newly generated target. These source to target mappings can be created manually. They can use auto map features within the tool to do some level of auto mapping, obviously. And then we can upload legacy Excel maps, or we can apply metadata driven automations to automatically create these source to target mappings. From those source to target mappings, we can then implement forward engineering smart connectors that will produce the SDK for any tool that provides an open API. That we recently implemented an instance with a large health insurance in the US where they are generating talent jobs in order to populate their data lake and their cloud data platform, Snowflake. For this, they are utilizing both the big data batch and standard DI versions. There are different SDKs, so however, we have smart connectors that will interact with these SDKs to produce that output. Right? These smart connectors are intelligent enough to identify the source and target types based on the definitions in the source to target mappings and produce the correct connections and components within that target ETL structure. Once we've dealt with network traffic and volumes of data, how we orchestrate and get that data migrated, these same smart connectors can be used to integrate new sources as they are incorporated into the enterprise. Right? Well, now that we have a solution to migrate that data, we now need to migrate the old ETL to load this new target that we've generated on the cloud. With Erwin Cloud Catalyst, we have a process of automated ETL conversion. This is a methodology that we follow. The first step is an automated ETL complexity assessment that will help us stratify that legacy ETL and really define a roadmap for the project to convert that to a new system. All right, and this is a multiple step process. We do utilize our reverse engineering smart connectors to document the legacy ETL into source to target mappings. It's a canonical model that we use within the Erwin Data Intelligence Suite. We then have Cloud Catalyst specific smart connectors that will translate that logic into the SDK of the target ETL. Again, any tool that provides an SDK, these smart connectors can be developed against. It's not a magic button. This is pattern based, and I'll go into those patterns specifically, but there are manual touch-ups required to some scenarios. Those are accounted for, and of course we unit test for completeness to guarantee that we are producing the identical output of that legacy ETL. And the first step of that ETL migration process is that automated complexity assessment. This is a programmatic approach that we have to decompose the legacy set of ETL. This instance was run against the 2,500 SAS data integrator jobs, and the target ETL was Azure Data Factory. So we make many passes at that legacy ETL set in order to really understand and provide that roadmap for the project ahead. It's going to identify how much automation can we apply, how much manual effort is needed, and then we can really put out a proposed timeline from that. The first pass really is a complexity stratification. We are breaking jobs down into simple, moderate, complex, and very complex, but it's a bit different than you see in typical stratifications. This is the complexity in order to apply automation to convert it to that targeted ETL. And the second pass we take is the load design patterns. And what we're looking for is very similarly orchestrated jobs that have the same distinct component list. And when we identify these patterns, we can identify sets of jobs that can be applied to metadata-driven automation. That means we can write a script that will convert 300, 200, 400, however many jobs fit that pattern automatically from one tool to another. Now, obviously, there is a diminishing return on the number of mappings that will fit a pattern. So that's where we do have some manual intervention coming in for the more complex mappings. We can apply automation, and these more complex mappings will benefit from the automation. However, that's where the manual touch-ups come in to complete orchestration or complicated user-defined components. Right. The last pass we do take is a component frequency itself. So we are looking at each distinct component that is utilized throughout the entire set of legacy ETL, and we are identifying how many times those components are used. Right? Obviously, sources and targets and expressions are going to be heavy hitters, but what we're really looking for here are really complicated custom components or external store procedure calls where we may need to look deeper into the complexity of what that ETL is processing. Another benefit of this analysis is that we can compare the legacy ETL to the target ETL and identify if that target ETL has equivalent components. In this case, we found out that Azure Data Factory is a maturing technology, does not have as many components as some of these legacy ETL tools. So that does not stop the automation. We can account for this by identifying patterns that will reproduce that same functionality within the target ETL set and reuse those patterns every time we identify that component being used. Now, there's also some automation possible with SAS user exits in this example. It's handwritten SAS macros that are also transforming data. We can do some level of parsing and automation with these technologies. However, that's again is where some manual touch-ups will be required. And once we've done all of this analysis, we've now identified how many patterns need to be developed, and those are smart connectors in the Cloud Catalyst suite to provide that automation, how much manual effort is going to be needed on top of that. And then we can put together a timeline of delivering one or two of these patterns per sprint, depending on the length of the sprint. And then the output, the mappings that were processed through that pattern, can go through the unit testing and UAT process while we begin to work on the next set of patterns. And in this iterative approach, we are able to deliver to the timeline as soon as possible. Okay. And as I mentioned, we do reverse engineer those legacy ETL sets. We take flat file exports or API connections, depending on the technology's SDK, and we are able to document that into the canonical model that is that source to target mapping. We then use the logic that is documented and implement a forward engineer smart connector in order to target and translate the functionality into that SDK of the target tool. I picked this example because it highlights the fact that we had an SCD2 component utilized, obviously, in many jobs in loading the data warehouse within that SaaS BI environment. Azure Data Factory does not have an SCD2 component. However, we were able to produce a repeatable pattern to accomplish that same functionality. And then in that conversion process, each mapping that utilized that component was able to come into a consistent load design pattern. Right? This is machine generated code. We are reducing human error and typos and providing that same consistent output over and over. We've done this for many cloud-based technologies, Spark-based tools, HDFS, Snowflake. In this case, we were populating Azure Data Lake through Azure Data Factory. And now we've taken care of that ETL migration or repointing of existing ETL. We don't want to leave the BI world out, as I mentioned before. So we do have an offering around semantic model conversion, and this use case has become more popular as of late. The most recent implementation was a large international retailer had a MicroStrategy implementation, and it was based off a multi-dimensional model. We were able to apply MicroStrategy reverse engineer to document all of the measures, attributes, and relationships that existed within that MicroStrategy environment. We are then able to apply more Cloud Catalyst smart connectors to convert that logic into a tabular model utilizing views and user-defined functions in order to mimic that multi-dimensional structure. Now, this comes in handy because their target BI tool was Power BI, a cloud-based version of Power BI, and it does not support that multi-dimensional function. So this, at the very least, it did not convert the reports themselves from one structure to another or one tool to another, but it did provide those BI developers with a familiar model to begin their new report development. All right, and then in addition, once we have moved to the cloud and everybody's happy, we can throw our hands up, climb to the top of the mountain and sing victory, and everybody's happy, but business changes, right? The landscape of business change and requirements change, and we're going to have to modify assets as they move forward in the cloud. So aside from the out-of-the-box capabilities of the standard data connectors that Sam was mentioning to document data at rest, they can be scheduled and keep track of versions over time. The same ability is available through our ETL and business intelligence reverse engineering smart connectors. They can be scheduled to be in coordination with the enterprise release schedule to constantly keep the source to target mappings and lineage up to date with the production environment. Our most recent addition to our reverse engineer smart connector library was Databricks. This was actually that same international retailer. They had implemented Databricks using PySpark. We were able to extract that PySpark source code and parse it into the source to target mappings to depict the logic that was happening within that code. Once those source to target mappings are integrated with the rest of the enterprise mappings and data intelligence suite, we are able to produce these lineage reports for a true end-to-end throughout the enterprise and beyond to the cloud. All right. And then once we have all of this great technical metadata and lineage documented, we can then begin the process of actually enabling data democratization. We can utilize the Erwin Business Glossary to define our business terms, rules, policies, and procedures, even custom categories to define the ontology of the business, and then associate that ontology to those technical assets, allowing businesses to discover not only those technical assets, but the lineage and how the data moves between those assets and how it's transformed along the way. And for a demonstration of any of these capabilities or a discussion on other use cases possible with Erwin Cloud Catalyst, please visit our website, erwin.com, and schedule a free demo.
Really interesting stuff, John. I think that I have a couple of questions before we get back into Cloud Catalyst, although, it's all one big thing, but I think that people are going to be really, really interested in this solution offering. And I thought you did a phenomenal job of kind of breaking it down for us. And Sam, I don't know when I've seen a better analogy of the chimpanzees and the chocolate chip cookies than
you
that.
said it here first.
I appreciate the level of creativity that it took to bring that, and so do all the people that have been sitting through sessions all day. So a couple of questions for you guys, and I don't care who takes what, just jump in. It's all in the family here. First one is, after reverse engineering, how do I refresh the lineage as artifacts change over time?
Excellent question. So I mentioned that we do capture changes over time, but we actually implement automated extraction procedures that will connect to GitHub or your source code repository or even directly to a file system and capture only the incremental changes, the deltas that have happened since the last reverse engineer. So we are constantly keeping the lineage and metadata up to date and in line with production without causing the huge network and performance traffic on the server.
Yeah, and just one other thing to add to that, John, on the front end, Marianne, we're using scheduled scans of our metadata for our source, target, and interim systems. And if we pick up changes from the source, like a column header change, for example, that can automatically be ingested, reversion the metadata, reversion the mappings, and it continues to perpetuate and maintain the documentation. So we're really bringing in both ends, any changes that occur, and making sure those mappings stay up to date, because those are what we're reading the lineage from dynamically. So our lineage views, our impact analysis views, all these great byproducts of having documentation are all up to date and easy to keep there with no extra effort.
Yeah, that's really great. I like both perspectives, and one of the things that's really interesting is we just got a paper from IDC. I think you guys both saw it, about business value. They interviewed in depth 4 customers of ours in different business segments, and one of the things that just kept coming back time and again was lineage, right?
Yeah.
And how what a giant problem for organizations lineage is, and how their lives are really changed after the implementation of the DI suite as far as lineage goes. So that's awesome.
You know, the real root cause there, and this is something that, you know, everybody in our audience will agree with. It's something that we all know, but we just haven't addressed it over the years, and it's that nobody likes documentation. You know, ETL developers write code. They don't like to write documents. Nobody, the exception of very few people, like to write documentation. So when we talk about data structures and managing data structures, the will it takes and the cost it takes and the people it takes to document every little step, every little mapping, and then maintain that with monthly release cycles and quarterly release cycles. Some of these companies have hundreds of releases per year. It's just an overwhelming task if you don't have automation behind it. So if we look at everything that's wrong in the data world, at its root, it's lack of documentation. That lack of documentation creates a fundamental lack of visibility. And this product, the DI suite, solves that. It's the biggest and best thing it does. And then what John's talking about is it does it automatically, which makes it even that much better.
Yeah, you know, and that's really interesting because you and I have spent a bunch of time in front of industry analysts, and we've been talking a lot about sort of our vision to automate everything. In fact, folks here in our studio audience for Erwin Insights heard Prashant and I earlier talking about our vision for automating everything, which is really the DI vision, right? And so much of the time we hear from the pundits and the smart people in the industry, they sort of conflate automation and AI, right? And while AI is absolutely a legit and important automation use case, if you will, there are so many things that cost businesses huge amounts of manual time that we are addressing every single solitary day with this solution set. So you guys want to just talk a little bit about that before we jump back into the other questions, because I think that that's a really important key. We have, you know, in 10.1 we have the very beginnings of AI and ML, which is important with our AI auto match. I think you talked about that before, but we really believe, and we've seen tremendous results, like a European-based pharma company, right, saving 80% of their man hours, right, redeploying those people into much more high-value work. By being able to do, you know, all of the automation of the smart connector. So let's just talk a little bit about that, and maybe some of the things that you've seen, Sam, in customers really bringing our level of automation and what Erwin specifically does, where our sweet spots are, into the mix there.
Yeah, so there's a couple of things to note here. So automation comes in many forms and flavors. Our audience has probably seen companies that do RPA, or robotic process automation. those things that RPA fixes are very, they tend to be very human oriented, very, instead of having somebody click, click, click 50 times for a document or to ingest something, they're having a repeatable program do that for them. The difference between, and that's good stuff, I think it's all worthwhile. It's arguable as to whether or not it's cost effective over the course of time or if it makes a big impact. When we talk about AI, the things that we're doing is saving time of specific experts and experts that are very expensive, not point and click people doing things in mass. It's people that have specialized skills in ETL, specialized skills as business analysts when we're talking about cross-referencing catalogs and tying that back with business terms. These are real, genuine time savings. You still need the experts. You still have to have, that human capital and that domain expertise to make sure everything's going the right way. But I think when we look at the things that we're solving on a grand scale with AI, it's pretty incredible. The stuff that John's talking about, the reverse engineering and the technical, the real key here with reverse engineering is that no ETL job is the same, right? No, company to company to company, they all do it differently. ETL developers are all trained differently. So by reverse engineering and then forward engineering machine generated code, we're getting better consistency. We're eliminating that human variable that says, I'm going to produce 1,000 ETL jobs with 100 people. And now I'm going to have to test for 100 different patterns and styles and other things. If you eliminate that factor and just generate code with a machine, testing the code becomes much more standardized and much more pattern-based. So I think the things that we're doing are very smart and they scale very well. And of course, we're talking about the future, right? When we talk about all those zettabytes of information and this IoT and everything else that's coming at us in the industry, it's really important that there's not enough people, right? It's not about eliminating jobs. It's about dealing with massive amounts of data and not enough people to make the wheels turn every day.
And the need for speed to insight, right? Because that's something we talk about every day, right? It's like if we had all the time in the world, it wouldn't matter, and we could do it as fast as we could.
And there are lessons to be learned just recently with this pandemic, right? The data wasn't there. We were running models against data that wasn't accurate, data that wasn't complete. So there's all sorts of things that the data science community is going to be looking at as a result of this. And one of those things is going to be speed, right? We couldn't get from zero to the truth fast enough. And I don't think we stopped long enough to think about it. So there's some lessons in there for sure.
Absolutely. So John, let me turn to you and ask you a question about this ETL stuff, because again, this is way above my pay grade stuff that I'm just still struggling to understand. So it's interesting to hear you talk about it. The automated ETL complexity assessment, that sounds like a lot. So how long does something like that typically take?
It does sound like a lot, and there's a lot of output from it. However, the typical timeline for the ETL complexity assessment is 2 weeks. And that is depending on if we have the technology you're looking to automate in existing inventory or if we have to build it. We can often deliver that within 1 week if it's in our existing library.
Wow. Okay. So that's a lot in 2 weeks. That's pretty amazing stuff, because that screen alone was pretty eye-popping for me. Sam, I'm just going to ask you this final question, and then we'll start to wrap up. But we throw some terms around sometimes. We don't necessarily take it slow and explain them to people. But we talk about standard connectors and we talk about smart connectors. Both of these again are huge part of the secret sauce and why we're as successful as we are, why people are buying our solutions, why we win, day in, day out over competition. Can you just break it down for folks, the difference between a standard connector and a smart connector? And then John, once he does that, will you just talk to us a little bit about building new connectors, right? And what the process or limitations are of that. If we come up against somebody, we know people have all kinds of crazy heterogeneous stuff in their environments, right? And what's the next big thing? So Sam, standard versus smart, and then John, what about new ones?
So the standard connectors are packaged with the product. That means that when you put the product in your environment, whether it's in the cloud, or on-premise, however you choose to deploy it, you're going to have connectors to reach out to your ERP, CRM, database management systems, flat files, JSON files. Any modern application with a JDBC connector can be connected to with our advanced JDBC connector, which will pull the metadata out and store it in our catalog. And it's metadata as is, and sometimes metadata is great, and sometimes it's very barren, but we have the opportunity once it's in our platform to enrich it, and then, of course, do change metadata capture over time, where we're picking up changes, we're archiving, and we can compare environments over time. So standard connectors, no added cost, it's all included with the product, and it gives you the power to catalog everything in your environment. Smart connectors are specific to technology that we want to reverse engineer and understand. Back to the documentation discussion earlier, when you ask an ETL developer if they documented something, their answer is yes, it's in the code. And it's true, it is documented and it is in code. The problem is the rest of us don't read or understand that code. So what we do, and what John's team does specifically with smart connectors, is they take that XML file, just to use standard ETL tools, and they break it apart and they basically decompile it into a source to target mapping document. That's going to give us clear indication of what our source systems are, what our target systems are, and then they break apart the rules. And those rules could be embedded SQL scripts, it could be pseudocode from any of the ETL tools, and we capture all of that. Things like loops and triggers and shared containers. All of the complexity in those ETL jobs gets poured out onto the page into a mapping document. Those mapping documents are then dynamically read by our solution to give you the full lineage views, the impact analysis, all those great things. And we do the same thing, not just for ETL, but also for stored procedure code. So for people that are stuck on very expensive hardware or things like massively parallel processing systems where you're doing ELT and using thousands of stored procedures, if you were to get off of that, you'd have to document all that stuff first. And we can do that in a matter of a very short time, get it all documented, and then point it where we want to go and generate the code to move it. So smart connectors are a la carte. So you buy them for whatever version of tool that you have. We have a massive inventory that you can find on erwin.com. And if we don't have something in inventory, like John said, it's just a couple weeks difference to get something developed and out to that particular client. So, and usually we've got other stuff that we're doing in the meantime, so we don't lose any speed, we don't lose momentum. Our time to value is our first order of business when it comes to implementation.
That's awesome. John, anything you want to add to Sam's explanation?
Certainly, just that the smart connectors are developed using an integrated development environment within the data intelligence suite called the Erwin Automation Framework. These smart connectors can be developed against any tool that provides an SDK. That SDK can exist in the form of an API, flat file exports in JSON or XML, or even direct database connectivity as a last resort. So in the limitation really becomes the availability of metadata through the SDK that those vendors are making available.
Okay, that makes perfect sense. So great conversation about the connectors, thanks. I just want to bring it back one more time to Cloud Catalyst because, again, I think that there's going to be a tremendous amount of interest. And my question is this, and I know the answer, but I just want you guys to tell again the live studio audience at home. Why are we positioned to have this sort of unique spot and this unique value in this overall proposition, right? From the data migration side to the data governance side. What is it about Erwin and our solutions that makes us, be able to occupy this space that quite frankly nobody else. There's point solutions on one side, point solutions on the other side, but nobody else has this comprehensive framework and offering. And just again reiterate for folks why that is, what those pieces are and how we bring it together.
Yeah, and my simple answer to that is our breadth, right? We go from the data modeling, we carry that directly into and cover every aspect of the system development lifecycle, and we go into the business side of things with bringing better insights, better context, better everything. The fact that we can do the automation piece of it, that's the secondary piece for most customers that I talk to. They want a governance program. They want their business users to have real access to data sets and to lineage views and impact views, all those things that are important that they've always wanted. I want to go see a model in a way that I can understand it, or a mapping document in a graphic format that makes sense to me. Once we've satisfied, those aspects of it with some parts of the solution, when we get down to how do we get this done, how do we get this done quickly, the automation is what really sells it, because we can go from, like I said, no data to no data in a matter of weeks. We're showing value very, very quickly. And for companies that are looking to modernize their architecture, Snowflake, right? That we just saw the other day, they went public, fantastic turnout. They're rocking it worldwide. But the answer to the question, we bought Snowflake, how do we get there? Cloud Catalyst is that answer. It's going to allow them to take everything that they've had working for the last 10 years, document it fully, pick it up, and put it in that high-performing, highly efficient environment called Snowflake. And they're going to, when they get done with that, they're going to have a comprehensive data governance program built in. Data lineage, mind maps, impact analysis, everything comes with it. It's a byproduct of doing things smart and fast.
And again, not just Snowflake, but Microsoft Azure, Google Cloud, and whatever comes next.
Yeah.
Any final thoughts on that, John?
I would just say I would agree with Sam's comment. I believe it's the breadth of offering that Erwin provides that is the differentiator. And not only that, it's the dedication to the development teams to integrate those offerings, to communicate with each other.
Yeah, I think that's a really great point. If you would move to the last slide for me, John, that would be awesome. And one of the things I wanted to say before I just talk a little bit about what's coming up next was, for a long time, we've been saying that every data modeler customer is a data intelligence customer. And I think that's never been more true than it is today with solutions like DM Connect for DI that helps us to automatically harvest that metadata from those data models and into the catalog, and now Cloud Catalyst. So again, if the folks who are watching right now are only DM customers and they have any of these needs, all you need to do is come and chat with us in the booth. One of the things that I wanted to say is the booth is open for a few more hours. Sam actually is going to be manning the booth. We've got a lot of our solution specialists, our sales guys, we've got folks from the services team. So please come visit the booth and the networking lounge, where you can meet with other customers and prospects who've got the same issues, questions that you do. And then following this at 12 p.m., the last track in the data intelligence content side is Data Forensic Files with Danny Sandwell. So I just want to thank you both for a terrific session. I think that this is going to be of great interest to people. Thanks for taking the time to be with us today, and thank all of you for tuning in to Erwin Insights 2020.